Okay, so here we are in 7.4 and we are approximating square roots. So our goal is to approximate square roots. So approximating means to estimate a value, right? So we're not getting an exact number, but we're figuring out an idea of the square root, right? A general idea for the value. So your first question might be, why do we need to approximate square roots? So to answer that, we are going to talk about real numbers and the different kind of real numbers and how they're classified. So we have a rational number is a number that can be written as the ratio of two integers. So a rational number, and that's what we have talked about, right? And a ratio here, that's like a fraction, right? So a rational number, any number that's 2/3, 4/5, 1/2. These are all rational numbers, right? They can be written as a ratio of two integers or a fraction, right? An irrational number cannot be written as the ratio of two integers. So the square root of any whole number that is not a perfect square is irrational. So think about it. The square root of 16 equals 4, right? So the square root of 16 is rational because 16 is a perfect square because 4 times 4 equals 16. Well, how about the square root of 15? Is there a square root of 15? No, there's not, right? This is an irrational number. And on the same note, the cube root of any number that is not a perfect cube is irrational. So the cube root of 27 is 3, right? Because 3 times 9 equals 27. So that's an actual answer. However, the cube root of 21, is there a cube root of 21? No, there's not. So the square root or the cube root of 21 is an irrational number. So the decimal form of an irrational number neither terminates nor repeats. So can you think of an irrational number off the top of your head that neither terminates nor repeats? Pi is a great one, right? Because 3.14, yada, yada, yada. It goes on and on and on. So to sum it up, an irrational number is the square root of a number that does not have, it's not a perfect square, right? The square root of a non-perfect square, the cube root of a not a perfect cube, and any number that cannot be written as a fraction, so a non-repeating or terminating decimal. These all need to be in your notes, by the way. So even though we have rational and we have irrational numbers, they're all real numbers. So they all fall under real number, right? And we can either go the rational route or the irrational route. So you see in the irrational pool over here that it's, again, those numbers that are not terminating or repeating decimals, numbers that are the square root or the cube root of not perfect squares and not perfect cubes, and then numbers that cannot be written as the ratio of two integers, right, or a fraction. On the other hand, if we go towards the red circle, we have several different groups or classifications, right? We have natural numbers, which are, you can think of natural numbers as counting numbers, so starting with 1, 2, 3, 4. So they're all positive and they're all whole numbers, right? And then you go up to whole number. So whole numbers are also natural numbers, right? And the only difference is that whole numbers include 0. So we're still at positive numbers and then 0. And they're all whole numbers, right? So every whole number is also a natural number, but every natural number is also a whole number, but not every whole number is a natural number, right? Because 0 is not natural. And then we move out one more class to integers. And the only addition here is that we now have negative numbers. So every natural number is a whole number. Every whole number is an integer. So by default, every natural number is an integer. But not every integer is a whole number or a natural number, right? Because negative numbers are not whole and they're not natural. But we're still, integers are always, they're not fractions, right? They're whole numbers, but integers can be negative or positive. and we move out then one more class and we hit rational. So everything in this red circle or red group, these are all rational numbers. But as you move out, the classes just get a little bit broader, right? Because now we have any negative or positive fraction or terminating decimal, right? Or repeating decimal. Those all fit into rational numbers. So like right here, we have 0.3 repeating. Right here, we have 2.25. So rational numbers, all negative and positive, fractions, whole numbers, terminating decimals and repeating decimals. Those are the rational numbers, right? But both irrational and rational numbers are real numbers. So it would be great for you to draw, not great, you need to draw these two families of numbers. Just kind of copy this chart in your notes. And once you have that copied, we're going to practice classifying real numbers so that we can figure out which groups they fall under. So remember that when classifying a real number, you need to list all of the subsets in which the number belongs. So if the number is 1/2, that you need to have natural, whole, integer, and rational number listed, because those are all the subsets that 1/2 belongs to. So you try classifying these real numbers. These should be in your notes, and we'll talk about them tomorrow in class. So even though an example would be the square root of 15 is an irrational number, we can still approximate its value, right? Think about on a number line. Well, if you go up 1, the square root of 16 is what? It's 4, right? Square root of 16. And if you go to 3, that's the square root of 9, right? Over here. So the square root of 15, it's really close to 4, right? So you could figure out how to compare values by approximating where it would lie on the number line. Let's look at another one. If we have the square root of 37, well, if I have a number line, the square root of 37, well, the square root of 36 is really close to that, right? And that's 6. And then the square root 7 is the square root of 49, right? So I'm just counting my whole numbers and then figuring out what are their perfect squares. So the square root of 37 is just a little bit bigger than 6, right? So if I was going to estimate what is the square root of 37, I would say it's about equal to, right? You do squiggly equal signs to say approximately 6.1. Okay? So now you try approximating some square roots. There's a few more practice problems for you, and we will go over these in class. So hit pause, go ahead and try and solve these, approximate them to the nearest whole number, integer, right? And then to the nearest tenth. So we can use these same ideas that we've been talking about to compare real numbers. So if we want to know which is greater, the square root of 5 or 2 2/3, well, draw a number line, and the square root of 5, well, that's really close to the square root of 4, which is 2, right? And this 3 would be the square root of 9. So the square root of 5 is just a little bit bigger than 2. And 2 2/3, right? This number here, this is going to be more closer to 3, right? There's 2 2/3. So which one's bigger, square root of 5 or 2 2/3? The answer is 2 2/3, right? And you can just draw it on a number line to show your answer. Okay, and here are your last few practice problems. So give these a shot, and we will talk about this more in class tomorrow.